Aloha and welcome. In this video, we're going to be talking about SRTP, LDAPS, and HTTPS. So we're going to start out with SRTP. And when we talk about this, we're talking about voice over IP. So to give you an idea of what voice over IP is, here I have a prop. It is my phone in my office. In the old days, everyone had a phone like this in their house, not exactly like this, but they would have a phone in their house and it would use a phone line with an RJ11 connector. These, though, use Ethernet connectors. So this is an Ethernet line. So if we look at this, you'll see that it looks just like the one that I showed in a previous video on connecting up your computer to a switch. So it uses the same kind of connector there. So this is an RJ45 connector. We're going to put this back in there and it's going to boot this up. It's also going to turn it on because the power is supplied through that same RJ45 connector. So this is voice over IP, essentially telephone through data. So this is supported by the SRTP protocol. So let's go ahead and jump into our text for that. So the Secure Real-Time Transport Protocol. It's a protocol for secure delivery of voice and video services over an IP network. Obviously, the one I had there was not video, but you could support video as well. So SRTP is an extension to Real-Time Transport Protocol, RTP. So our SRTP is used in voice over IP, which is what I just showed you, video teleconferencing applications, streaming video, devices that have push-to-talk functionality. So SRTP, it provides confidentiality, authentication, and integrity for data in both unicast, which is one-to-one communications, and multicast, which is like one-to-many communication applications. So SRTP uses the advanced encryption algorithm, AES, using counter mode, which we talked about in previous video. For encryption, and it's going to use HMAC SHA-1 or HMAC MD5 to ensure the data integrity and authenticity. So furthermore, SRTP, it defends against a replay attack. A replay attack is one where you take packets and you reuse them. So it sequences these, so it has a sequence number on each of the packets that it receives. Because when you're doing video or something, you're going to be sending one after the other. You're going to send this long stream of them, and these replay attacks are where they try to take a previous packet and put in their bad stuff and then resend that. But what happens with SRTP is it actually keeps track of the packets. They each have a sequencing number. So if it gets a packet that it knows it's already received that sequence number for, it's going to toss it out. Another thing to keep in mind is SRTP, it uses UDP for port 5004. So that's important to remember. So remember I mentioned before that TCP is usually used for things that we need to know, terminate. We want to be able to do error correction and things like that on it. So TCP is kind of more, I wouldn't say it's more stable, but it's more robust. UDP is kind of fire and forget. So UDP, we're using UDP here because we're talking about video and audio, and it doesn't make sense to resend a little blip of audio if it's corrupted or something happens in transit. It's better to just drop it and then continue on because it may not even be perceptible in the video stream. So we're using UDP for this. So it's UDP port 5004. And then we're going to talk about LDAP. So we're actually talking about the secure version, which is LDAP S. But first, we'll start out with an explanation of what LDAP is. So LDAP is Lightweight Directory Access Protocol. It's a protocol for accessing and maintaining distributed directory information services over an IP network. So it's often used to share information about users, systems, services, and applications that you have in a network that people can access. So it's commonly used to give username and password information. It's where you keep all that information at, and it's used in Active Directory for Windows Server 2019. So the problem with LDAP is, like a lot of these other things that were developed in a more naive time, there's no security built into it, so everything is transmitted in clear text. So because of that, we now have LDAP S, or LDAP Secure, or LDAP over SSL, and that uses SSL TLS to protect the LDAP transmissions. So in LDAPS, client and the server, they're going to establish an SSL TLS connection before they transmit an LDAP message. So after it's done, you're going to close the connection, and when you're going to close that when it's over. So the LDAP S, you're going to need to remember this too. It uses TCP port 636 by default. So again, you should have a table that you're creating that has your which protocol it's using. Is it TCP or is it UDP? What the port number is and what's using it. And this is going to be LDAP-S. So you'd have TCP 636 LDAP-S. And that's going to, you'll need that when it comes time for the exam. But it's nice to know all these things and keep that in your head, because if you ever take the Networking Plus exam, you're going to see a lot of the same things in there. So applications that use LDAP might be vulnerable to LDAP injection attacks, kind of like the SQL injection attacks that I mentioned, but it's when an attacker is going to exploit an input validation vulnerability. They're going to try to create some kind of a thing that's going to mess with the query on the back end. So it says here an LDAP injection attack may result in modification of LDAP content or granting permissions to unauthorized queries, which is exactly what you don't want. So you always want to make sure that if you're doing LDAP, that your input screens are you want to make sure that your inputs are validated. You want to make sure they're cleansed before they're actually accepted and used. Then we get to HTTPS, which is something that most of us have probably worked with. So when you connect to a web nowadays, I forget how many years ago it was, Google said that it will no longer connect to websites that don't have some kind of a digital certificate, an SSL certificate. So now most sites that you go to will have an SSL certificate. So what is that? Well, let's look at this. So Hypertext Transfer Protocol Secure, HTTPS. It's also known as HTTP over SSL, HTTP over TLS. It's an extension of HTTP, and it uses SSL or TLS to establish an authenticated encrypted connection between a client and a server. So you use HTTPS for secure data exchange between a web server and a web browser. And that way, nobody can snoop the traffic that's going back and forth. So this works on layer 7. It's the application layer of the OSI model. And it's going to be using port TCP 443. And I've talked about this a lot in my videos in the past, but when you're doing HTTPS, you're on 443 by default. So HTTPS, it's going to rely on cryptographic services provided by SSL TLS to secure the data. And it's going to use digital certificates for authentication, encryption for data confidentiality, and message authentication codes MAX for the data integrity, those hashes that we talked about before. So HTTPS supports mutual authentication from client to server, server to client. HTTPS protects against the man-in-the-middle attack that we talked about in the previous lesson, and the eavesdropping and tampering of data exchange between a web browser and web server. And it prevents against that, because even if somebody is taking your data, if they're in the middle and they're taking your data and moving it on, because it's encrypted, they can't do anything to it. They can't access that. So that's the good thing about this. And you can look and see the process of setting that up. You can look in here. So you've got your web browser. It's going to request an HTTP session from a web server. So the web server is going to send back the digital certificate. And remember, in the digital certificate, their public key is in there. And that's why it's saying the digital certificate. So the web browser is going to create a session key, a symmetric key, and encrypts the session key with the web server's public key that's obtaining from that digital certificate. So the web server then is going to decrypt that session key with the private key that it holds, and then it's going to encrypt the word finish with the session key and send that encrypted message to the web browser. So at the web browser end, it's going to encrypt finish with the session key and send the encrypted message to the web server. The HTTP session data is encrypted with the session key after that. So that's how that handshake there goes. And that's called the HTTPS SSL TLS handshake. And that's it for this lesson. If you have any questions, feel free to reach out to me. I know that there's a lot of port numbers that we're talking about here, and a lot of technologies that you may not be familiar with, but if there's anything I can do to help you understand what that looks like, just reach out to me and I will be happy to help. Until the next lesson, take care.